right, we are starting topic 19, which is the second topic in this section of circles. And today we're going to just review some vocabulary about circles and investigate a conjecture about the perpendicular bisector of a chord. So the first thing we're going to look at is just this example here, and it talks about Travis wants to build this gazebo in his backyard, and the floor of the gazebo is a circle, and it has a 12-foot diameter, and he wants to use 2x4 redwood planks and lay them side by side. And then he needs to determine how many planks he needs to buy, and they're each 2x4, 4 inches wide. So he calculates the number of planks needed to cover the 12-foot diameter as follows. So 12 feet across is the same thing as 144 inches. And if each plank is 4 inches wide and you divide that, he would need 36 planks. Okay. Now, depending on the length of them, if he buys 12-foot sections, then he would have, eventually it would fit here. But what would happen to the planks as he moves out? They're gonna get shorter and shorter and shorter. Okay, and so he probably doesn't really need 12-foot. He could get away with probably shorter than 12-foot by 8-foot sections, because he's gonna have a lot of leftover wood here that he could use then to fill in the gaps. So today we're going to talk about chords, and that's what this segment represents. And that segment is the diameter, which is the longest chord in a circle. The arc that it intercepts is a semicircle. So here is your picture of this circle here with this chord. And again, a diameter is a chord, and it intersects the semicircle. So it cuts the circle in half. As the chord moves away from the center of the circle, what happens to the length? Well, the length of it gets shorter, and then the arc that it intercepts is also going to be shorter. So this arc would be 180 degrees, and as you move this from the center, that arc is going to be less than 180 degrees. All right, so then it just says, if you don't know how to find the center, or if you don't know where the center is, how might you find it? And so that's what we're going to talk about today. So the first thing is your vocabulary down here in this second half of your sheet, and it just says a segment whose endpoints lie on the circle is a chord. So here we have some different examples of chords. We've got chord segment DE. This is a chord. Its endpoints are on the circle. DF, that segment DF is not a chord because F is not on the circle. And again, this is your diameter, which is a chord. So segment AB is a chord because its endpoints are on the circle. Segment CF is not a chord because its endpoints are not on the circle. So as long as the endpoints are on the circle, then it is considered a chord. All right, there are two different types of angles that we encounter in circles. We have central angles and inscribed angles. A central angle in the circle is an angle in the plane of the circle whose vertex is the center of the circle, and the sides of the angle are both the radius, radius in the circle. So here in circle A, you've got radius AB, and you have radius AC. And so this angle right here, angle BAC, is what we call a central angle. Okay, and so in your notes, when it says what is a central angle, we could say angle BAC, or we could say angle CAB. But again, the sides of the angle are both the radius of the circle, and then the vertex is the center of the circle. The relationship between the central angle and the arc that it intercepts. So this is the arc that is intercepted or created by this angle. So when you draw this angle starting at BAC, so the arc that connects B to C is congruent to the central angle. So if this angle here, let's say, is 40 degrees, then this arc is 40 degrees. So this would be 40 degrees of this entire 360. So the relationship between the central angle, and which is right here, and the arc that it intercepts, they are congruent. So for number 3, it says, what is the relationship between the minor arc and the central angle? And you're just going to put they are congruent. All right. The next angle is what we call the inscribed angle, and that's what you see here in blue. The inscribed angle is an angle whose sides are chords of the circle. So BD is a chord and CD is a chord, and the vertex is on the circle. Okay, so angle BDC is an inscribed angle. So the difference between the central angle and the inscribed angle, the central angle, the vertex is the center, and in the inscribed angle, the vertex just is on the circle. And the relationship between the inscribed angle and the arc that it intercepts. So this angle right here, angle BDC, intercepts the same arc as our central angle did. It starts at B and it ends at C. But this angle here is not the same measure as this angle. So this angle is congruent to the arc, but now this angle, this is in the middle of the circle. So if we stretched it all the way across, we're actually making that angle smaller. And since we're going, this is half the circle. And so since we're covering the other half of the circle, this angle right here is going to be half of that angle. So this angle, the inscribed angle, is half of the arc that it intercepts. All right, the arc of a circle is 2 points on a circle and the unbroken part of the circle between them. Okay, so if you take 2 points on the circle and you look at the part of the circle that connects those, that is what we call an arc. The semicircle is half the circle. And it just says that if the whole circle is 360 degrees, the measure of a semicircle is 180 degrees. The arc that is smaller than a semicircle is what we call a minor arc. So if this is the diameter, then any arc that is within this semicircle here is considered a minor arc. So like arc DE is a minor arc, arc BD is a minor arc, arc BC is a minor arc, or you could even say arc BE from B to E because that's less than 180 degrees, or D to C is also less than 180 degrees. To name the arc, you use the arc symbol and you're just using the endpoints of your arc, so like BC or CB. So you've got your arc symbol, and then it just says that the arc that the central angle BAC and the inscribed angle BDC intercept is arc BC. And again, make sure you put that symbol above it. The semicircle we said was half the circle, so its measure is 180 degrees. The example of the semicircle in this figure is arc EC. Okay, and again, the minor arc, an example of a minor arc, I would just say, we'll just say DC. So DC is the minor arc. Okay, now keep in mind BC is also a minor arc, but DC is the minor arc. Now a major arc is an arc that's more than 180 degrees. So it's labeled here in green. So if I start at B and I go the opposite direction all the way around, that's more than 180 degrees, less than 360, and so this is considered a major arc. To name a major arc, we use 3 points. We use the point where it starts, a point that it intersects, and then a point that where it ends. And the reason is because if I said arc BC, you don't know if I'm talking about this arc or this arc going the other direction. So the minor arc, we use the 2 points that start and stop the arc, and then the major arc, we use 3 points where it starts, one point where it intersects and then where it stops. So I could say arc BDC. I could say arc BEC, or I could even say arc BFC. So any of those would be correct ways to name it. So we'll just say BFC. And again, it has that arc symbol above it. Okay, so a major arc uses 3 and a minor arc uses 2. I've already answered this question about the central angle and the arc that it intercepts, and we said that it was congruent. We talked about this one and how that the inscribed angle, this angle right here, is covering double the distance away from this arc, and so it's going to get twice as small. So this angle is going to be half of that angle, and if these two are congruent, then this angle is half of the arc. So for an inscribed angle, the relationship is it's half of the intercepted arc. So if this arc here is 50 degrees, then this angle is 25 degrees because it's half of that. Remember, this would be congruent. It would be 50 degrees because these are congruent, the arc and the central angle. All right, let's just look at some examples, kind of the same picture we had. And it says, if angle CAB is 50 degrees, find the measure of the arcs and the angles. Right, so I'm going to label what I know. I know that angle CAB is 50 degrees, and that's my central angle, so my arc is also 50 degrees, which makes the inscribed angle 25 degrees. Okay, so the measure of arc CB we've labeled, that's 50 degrees. The measure of angle BAE is this angle right here. Okay, well remember that this angle right here and this angle here form a linear pair, and so if this is 150, if that's 50, this is 130 because they have to equal 180. Another way you can think of that is this is a semicircle. So if this is 50 degrees, from B to E is going to be 130 degrees. And so this is a central angle because it's formed at the center and it's going to be congruent to that arc. So this is 130 degrees. Arc BE, what I was just describing, is that minor arc starting at B, ending at E, and it's formed by this central angle, which is 130 degrees. And then arc BDC, so starting at B, going through D, and ending at C, is going to be 360 minus 50 degrees, which is going to equal 310 degrees. Okay, so starting at B, all the way around, all the way around would be 360. So if I take away that 50, I have 310 degrees.